Assalamualaikum and welcome to the video. I am Aziman bin Abu Bakar here from Physics Unit KMPK. In this video, we are going to go through experiment for linear momentum. What we hope you to get from this video is that you can appreciate the practical session in facilitating your learning of physics, hence making the learning meaningful. Because some of the apparatus might be foreign for you, we introduce them in the video. Reading the procedure with no background knowledge could be confusing and intimidating, so we go through the setup process for you and we hope the procedure will make more sense to you. We are not going through the procedure step by step, but rather we are giving you the overview of the experiment and great tips to help you with the experiment. Make sure you have with you the lab manual and open them to page 13 on the experiment of linear momentum. And also you are going to need your jotter to jot down important information and tips as you go along with the video. Before going to the lab session, make sure you have the objective, a brief summary of the procedure, and table for data collection ready in Jotter. You can also add sketches as a visual tool to help you with the procedure. It does not need to be perfect or beautiful, just keep it loose. In this experiment, we are going to verify the conservation of linear momentum. For the theory of conservation of linear momentum, we have equation 4.1, m1u1 plus m2u2 equal to m1v1 plus m2v2. So we substitute equation 4.4, which is u equal to r square root of g over 2h into equation 4.2 and 4.3. As the result, we will get the equation for x-axis is m1 x naught equal to m1 x1 plus m2 x2, and for the y-axis we will get the equation 0 equal to m1 y1 plus m2 y2. Setup for figure 4.2a is used to find the value of x naught. Meanwhile, the setup for 4.2b is used to measure x1, y1, and x2, y2. After the oblique collision, ball bearing 1 and ball bearing 2 will fall on the carbon paper and the position will be marked on the drawing paper as shown in the figure. Next, we will replace the value of m1, x naught, x1, m2, x2, y1 and y2 into the equation for x and y axis in order to verify the conservation of linear momentum. The procedure that we are going to do is, the first one, we will release ball bearing 1 without collision. Secondly, we will release ball bearing 1 to collide with ball bearing 2 in order to produce oblique collision and verify the equation of 4.5 and 4.6. Finally, before we go into the apparatus and setup video, we have to weigh the mass of ball bearing 1 and 2 and then record them. Repeat the experiment for 5 times and record the value of x naught in the table. Then we calculate the average value of x naught. Next, for the oblique collision, repeat the experiment for 4 times and record the value of x1, y1 and x2, y2 in the table. Then, we calculate the average value of x1, y1 and x2, y2. Make sure to enter the uncertainty for your measurement. Let's go to the apparatus and setup. We are using a curved track, 2 ball bearings M1 and M2, a piece of string to tie on pendulum bob, a pendulum bob, a meter rule, plasticine to stick the string. We have a piece of drawing paper, and a piece of carbon paper. First of all, our curve track needs to be placed on the flat table. We will use the drawing paper for the ball bearing mapping and fold it into two sides. Therefore, we will have a straight line in the middle of the paper. To prevent our drawing paper from moving, we need to put the cellophane tape on each of the corner of the drawing paper. We are going to slide the plywood near to the end of the table. By adding the plasticine, we can hold the pendulum string and keep the track horizontal at the end. In order to align the track center with the center of drawing paper, we use the pendulum and string and tie it below the curved track. Make sure that the pendulum is placed at the center of the paper by referring to the middle line. Mark point A on the curved track as the starting position for ball bearing 1. We will release ball bearing 1 from point A and observe the landing point of ball bearing 1 on the paper in order to place the carbon paper on top of a drawing paper. Next, we release the ball bearing 1 from point A for 5 times to get the average value. We mark the position of the landing ball bearing 1. We are going to measure the length from the landing point to the middle of the pendulum bob as X node. To begin an oblique collision, we need to place ball bearing 2 at the end of the curved track. Release ball bearing 1 from point A, and these two ball bearings will subsequently collide and fall freely in a projectile motion. Repeat this step for 5 sets of reading. Next, we will observe the landing point of ball bearing 2 and measure the distance by referring to the central line. After that, we will observe the landing point of ball bearing 1 and measure the distance by referring to the central line.